So after the stage of the firing level, which is minus 70, minus 55 millivolts, the next stage is depolarization. During depolarization, the interior of the cell becomes positively charged, while the exterior of the cell becomes negatively charged. So there is electropositivity inside the cell and electronegativity outside the cell. It simply means that the resting membrane potential is completely altered. Because initially, resting membrane potential, during resting membrane potential, the interior of the cell is what? Negatively charged, and exterior is what? But as soon as depolarization starts, the interior of the cell becomes positively charged, while the exterior becomes negatively charged. And depolarization is due to the influx of sodium ion from the ECM to the ICM of the cell. Alright? I said depolarization is due to what? Influx of sodium ions from the ECM to the ICM of the nerve cell. Look, the nerve cell, the membrane of the nerve cell have some ion channels. I said the membrane of the cell or nerve cell have some ion channels. Alright, if you look here, you will see a channel or a pump for sodium ion. Okay? Let's take this as the exterior. Let's take this as the ECM. Alright? Remember that the ECM have more sodium ions, right? Am I right? So you have more sodium ions in the ECM. Okay? And then let's take, there are channels or pumps. The first pump that you have here is sodium ion pump. Alright? Now, during depolarization, there is influx of sodium ions from the. So are we following? Depolarization is due to what? Influx of sodium ion from the ECM to the ICM. So you have sodium ion enters the interior of the cell. Let's take here as the ICM. Alright? Good. So you can see sodium ion entering the interior of the cell through its pump or channels. And when sodium ion is entering the cell moves from electronegativity to electropositivity. So the graph continues to grow until it gets to the zero mark. Look, it's moving from minus 70 to minus 55, which is the firing level, and continues to minus 40, minus 30, minus 20, minus 10, until it gets to 0. Okay? More sodium ions are entering. So it continues. The positivity inside the cell continues to grow. Good. So the next stage is the overshoot. An overshoot simply means that the polarization has passed the 0 mark. It has moved completely from negativity to the 0 point, and it's going upwards to positivity. Alright? So it's getting from 0 to plus 10 to plus 15 to plus 18 to plus 30 until it gets to its peak, which is plus 35. Plus 35 millivolts. So I said the next stage is overshoot. And at overshoot simply means that the polarization has exceeded the 0 mark. Okay? The next stage is the peak. From overshoot, the polarization continues until it arrives at its peak, which is 35 plus 35 millivolts. At the peak, it means that the polarization is complete. The cell is fully depolarized. Okay? And then, yes, fully depolarized. Alright? It has reached its peak. So the next stage is repolarization. When the polarization is complete, the sodium ion channels closes. When the polarization is complete, look, these sodium ion channels closes. It's closed. I repeat, we are on the repolarization. That's stage what? Stage what? 8. Good. When the polarization is complete, the sodium ion channels closes. When it gets to its peak and repolarization starts, these sodium ion channels closes, preventing sodium ions from entering the interior of the cell from the exterior. Alright? The potassium ion channels opens. There's another channel on the membrane of the nerve cell. Alright? This is this channel is also found on the membrane of cells, nerve cells. At repolarization, sodium ion channels closes. Potassium ion channels opens, causing the air flux causing the airflows of potassium ion from the interior of the cell to the exterior of the cell. It means that potassium ions are moving out of the cell to the exterior. It's moving from the ICF to the ECF. Remember, we have more potassium ion inside what? Inside the cell. Am I right? The airflux of potassium ion via its channels from the interior to the exterior is what is responsible for repolarization. Alright? So you have potassium ion influx of sodium ion means entry of sodium ion from ECF to ICF. Influx. Airflux of potassium ion means exit of potassium ion from inside the cell to outside the cell. You should have these terminologies on your fingertips, please. So when I say influx of students into the classroom, it means students are entering the classroom. If I say airflux, it means what? We are going out of the classroom. Alright? So the next stage is hyperpolarization. Hyperpolarization. Remember that as potassium ions are leaving the nerve cell to the exterior, inside of the cell gradually becomes electronegative, while outside gradually becomes electropositive. Alright? Because repolarization simply means that the cell is returning to its resting membrane potential. So I was saying the next stage is hyperpolarization. Once repolarization is complete and the cell has returned to its normal resting membrane potential of minus 75. Repolarization overshoots its mark of minus 75 millivolts. It simply means that more potassium ions are leaving the cell in essence, and that leads to repolarization overshooting its mark of minus 75, minus 70 millivolts. And that is why the graph goes below the minus 70 millivolt mark. And this stage is known as hyperpolarization. It then means that there is excess negativity inside the cell than positivity outside the cell. Hyperpolarization. Hyperpolarization would also be due to the opening of the sodium potassium ATPase pump. Sodium potassium ATPase pump. Have you heard of sodium potassium ATPase pump? You have sodium, let me write it here. Sodium potassium ATPase. That thing is ASE. Okay? Sodium, potassium, ATP formed. You write capital A, capital T, BASE. Sodium, potassium, ATP formed. Alright? So I was saying that hyperpolarization can also be due to the opening or the activation of the sodium, potassium, ATP form, which are also found on the membrane of the cell. Alright? This form will move out three sodium ions. It pumps out 3 sodium ions and pump in 2 potassium ions. Alright? It pumps out 3 sodium ions for every 2 potassium ions that is carried into the cell. Sodium, potassium, ATP form. So in that way, the cell will now become not only polarized, but hyperpolarized. And this can be more active when we talk about action potential of skeletal muscle. Alright? Good. I hope that is clear. Good, how long can you think this? This one is too simple now. Right? I learned this thing in my primary school. Is it difficult? We learned it in Nursery 1. Okay. So this thing is simple. I learned it in my primary school. Look, the mechanism is simple. First, you must note that there are 3 main pumps on the surface of the cell membrane. The first pump is the sodium ion pump or the sodium ion channel. The second one is the potassium ion pump or the potassium ion channel. And then you have the third one, which is the sodium potassium ATP pump. These pumps enable the flow of ion into and out of the cell, and they bring about depolarization and repolarization of cells. Alright? Good. For example, when the cell is in its resting state, the interior of the cell is negatively charged, while the exterior is positively charged. When action potential begins and depolarization starts, the sodium ion pump is split open, and then there is influx of sodium ion from the outside of the cell to the inside of the cell, causing an alteration of the normal resting membrane potential. It means that you now have more electropositivity inside the cell and electronegativity outside the cell. Alteration of the resting membrane potential. And that is due to influx of sodium ion, positively charged ion, from exterior to interior of the cell. There you have depolarization. It continues until it reaches its peak, which is plus 35 millivolts. And when it gets to its peak, the interior of the cell is fully electropositive. Alright? Because more sodium ions are entering into the cell from the exterior. As soon as the polarization reaches its peak, the sodium ion channel or pump closes, preventing more sodium ion from entering the inside of the cell. So what happens? Depolarization starts, and that is when you see the graph begins to come down. It was going up before during depolarization, but as it goes to its peak, it begins to come down. What happened? What is the mechanism behind that? Closure of sodium ion channel. Prevention of sodium ion from entering the interior of the cell from the exterior. The second thing that happens is opening of potassium ion pump or channel. We have more potassium ions in the cell. So this potassium ion begins to leave. There is airflow of potassium ion from the interior of the cell to the exterior of the cell. Alright? Then there is a gradual return of the polarity of the cell, which means that the initial electropositivity that was created due to depolarization or action potential is now altered inside the cell. So the cell will now want to return to its resting membrane potential state. Alright? So as potassium ions are leaving, the interior of the cell gradually becomes electronegative, while the exterior becomes electropositive. And as this potassium ion continues to leave the cell, repolarization becomes more deep and strong. At the point it gets to its normal polarized state, the resting membrane potential of every nerve cell is minus 70 millivolts. So as soon as repolarization reaches here, the interior of the cell is fully electronegative, while the exterior is electropositive. So there is a return of the polarity of the cell, the initial resting membrane potential. Names have meaning. Repolarization. Repolarization. Return of polarity of the cell. Where the cell becomes, the interior of the cell becomes electronegative and the exterior becomes electropositive. This repolarization can even, as in, graduate to hyperpolarization, where you now have excessive negatively charged ions inside the cell as compared to the positively charged ions outside the cell. And sometimes it is due to sodium potassium ATPase form, which will bring out more sodium ions that has already entered the cell during depolarization. So it's bringing out more and returning the, what is it called, potassium ion that was even leaving the cell during repolarization. It's returning more potassium ion into the cell and taking away more sodium ion. Right? It's simple, very simple. So if you see the exam, I hope you can just smash it without even thinking twice. Very simple. Alright. So you need to go and study membrane potential of nerve cell, muscle cell, or muscle fiber. When I'm talking of muscle fiber, I'm talking of skeletal muscle fiber and the heart muscles. Go and study the membrane potential of nerve cell, membrane potential of the skeletal muscle, and membrane potential of the cardiac muscle. Go and study them. So that is first assignment. Going forward, Our next topic is synapse. Synapse. So stay have plenty time. So, and the light is on. All for you. And there is also food and drinks for you. Are you tired? It's just 12. It's not even up to 12. This one, she gave me my report that's not. Really? Are you serious? Oh, after one. It's not even up to 2 o'clock. I am shouting. Is it even for lunch? It's not lunchtime. Our lunchtime is 2 p.m. And I think we have an agreement with the staff that once it's 2 p.m., we'll all go to ShopRite or a celebrity there, we'll enjoy ourselves and we'll come back. Did you contact the other lecturers who called you? You said? Okay, we'll take 10 minutes break. Call him. Call him to come. Alright? Yes. Any question? Yes, quickly.